Good morning to everyone. Myself Kundana. I'm working as assistant professor in BVRIT Narsapur, in the department of BSH. Now, in this session, I'm going to teach about water technology. So, let us start our topic. Water technology. We know that water is the main resource for each and every living organism that are present on our earth. Even though three-fourths of our earth is covered with the water body, we are facing deficiency with the drinking water. Why the deficiency is happening? What makes the water not suitable for consumption purpose? How to determine the impurities that we are going to discuss in the topic. So first point, we know that water is a universal solvent. It is a universal solvent. So why water is known as universal solvent? As all the compounds present on our earth are able to dissolve in the water. Because of that reason, water is a universal solvent. Okay. And there are two types of water. First one, soft water, and second one, hard water. So what do you mean by soft water? What do you mean by hard water? First we will discuss this topic. Soft water. When we wash our hand with the soap, the water which gives more amount of lather with the soap is known as soft water. So the water which gives more lather with the soap is known as soft water, and the water which gives less amount of lather with the soap is known as hard water. Which gives less lather with the soap is known as hard water. Next, why soft water is able to give more amount of lather? Why hard water is not able to give more amount of lather? That we will discuss now. Reason. If you take soap, what is the formula of soap? The formula of soap is sodium stearate. So, Na stearate, Ste stearate, or we can write this one as C17H35COO Na, sodium stearate. When it is reacted with the normal water, then what is happening here? You are getting sodium hydroxide plus stearic acid, C17CH35COOH. But whereas in case of hard water, what this soap is reacting with, that means your sodium stearate is reacting with calcium and magnesium ions that are present in the water. Because of that reason, we are getting calcium stearate plus sodium ion. So due to this calcium stearate formation, the water is giving less amount of lather because this is highly insoluble in water. It is highly insoluble in water. So based on this criteria, there are two types of water. So soft water, hard water. Next, why hard water is giving less amount of lather? Just now we discussed that. So due to the formation of your calcium stearates and magnesium stearates. Why that water is consisting of calcium and magnesium ions? So that we are going to discuss now. That topic is hardness. Hardness of water. So what do you mean by this hardness? So hardness of water is mainly caused due to the presence of calcium and magnesium salts. So what are the salts responsible means? They are carbonates, 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 bicarbonates, bicarbonates, chlorides and sulfates. So mainly hardness of water is caused due to the presence of calcium and magnesium salts. That means it is mainly caused due to calcium carbonate, calcium bicarbonate, calcium sulfide, calcium chloride. The other one is magnesium carbonate, magnesium chloride, magnesium sulfate and magnesium bicarbonate. So mainly hardness is caused due to the presence of these 8 salts. And if you observe, when we boil the water in our daily life, we are going to observe the things. So to remove the hardness present in our water, we used to boil the water. So when we are boiling the water, some salts can be easily removed while when water is boiled to 100 degrees centigrade. So based on this removal, hardness is classified into 2 categories. Number 1, temporary hardness. Temporary hardness. Number 2, permanent hardness. Permanent hardness. So what do you mean by temporary hardness? What do you mean by permanent hardness? Temporary hardness. The name itself is indicating temporary. That means hardness which can be removed by boiling. Hardness that can be removed by hardness that can be removed by boiling. That can be removed by boiling is known as temporary hardness. And the hardness which can't be removed, which can't be removed by boiling is known as permanent hardness. Okay. Next, what are the reasons? What are the reasons for temporary hardness? Why this temporary hardness is caused? This temporary hardness is mainly caused due to the presence of your carbonates, and bicarbonates, and bicarbonates of calcium and magnesium. So temporary hardness is mainly caused due to the presence of carbonates and bicarbonates of calcium and magnesium. But whereas in case of your permanent hardness, this permanent hardness is mainly caused due to the presence of your chlorides and sulfates of calcium and magnesium. So permanent hardness is mainly caused due to chlorides and sulfates of calcium and magnesium. Next, how to remove temporary hardness? We discussed that. Temporary hardness can be removed by your boiling purpose. Then how to remove your permanent hardness? Permanent hardness can be removed by some treatments. What are those means? Ion exchange method, Kalgan conditioning method, zeolite process, lime soda method, like that. So these are the methods used to remove permanent hardness. These are the methods used to remove permanent hardness. Next topic. So till now discussed that what is different types of water, what are the different types of water, and how we are classifying the water, and hard water is mainly caused, why it is responsible means hardness, and how many types of hardness are there. Just now we discussed that. Now how to measure hardness? Next topic, how to measure hardness. How to measure hardness. For every thing we are going to measure. If you go with the distance can be measured in terms of kilometers. If you go with the density it can be measured in the terms of your thickness. And if you go with the surface tension, 9 per centimeter. Like that, for everything we are going to measure. Like that, this hardness can be measured in terms of ppm. So what do you mean by this ppm? Means parts per million. Parts per million. So this is the unit which many of you learned during your intermediate. But apart from that, there are some more units to measure the hardness. What are those? Means the next one is milligram per liter. Next one, degree Clark. Next one, degree French. So these are the units to measure hardness. ppm, milligram per liter, degree Clark and degree French. So these are the units that are used to measure hardness. So here there is a relation. We know that meters can be converted into kilometers, kilometers to be converted into millimeters. Like that, there is a conversion. In the same way, hardness units also can be correlated. So it can be related. How it can be related means 1 ppm is equal to 1 ppm is equal to 1 milligram per liter, which is equal to 0.07 Clark, that equal to 0.1 degree French. So this is the relation between the units. So how to measure hardness means ppm, milligram per liter, degree Clark and degree French. What is the relation means 1 ppm is equal to 1 milligram per liter, that equal to 0.07 degree Clark, which is equal to 0.1 degree French. As it is very important topic for your 2 marks question, as it is important for doing problems also. Okay, next one. We know that hardness is caused mainly because of your carbonates, bicarbonates, chlorides and sulfates. But among all this one, carbonates are highly insoluble. And if you go with the molecular weight of calcium carbonate is 100. To calculate the hardness of any sample, suppose any district water is taken and we need to determine the hardness of particular sample, we need to go with the calculation part. At that moment, as the molecular weight of remaining salts are different, so it's very tough to do the problem. For that sake, all hardness causing salts, calcium carbonate equivalents. So what we are going to do? All hardness causing salt, all hardness causing salts are converted into calcium carbonate equivalents. Why? There are 2 reasons. So calcium carbonate is highly insoluble. It is highly insoluble in water. That is one reason. Second one, as the molecular weight of CaCO3 is 100, it is easy to calculate. It is easy for calculation. This is also very important for 1 mark question. So, why hardness causing salts should be converted into calcium carbonate equivalents means the first reason, this calcium carbonate is highly insoluble in water, and the second one, as the molecular weight of your calcium carbonate is 100, it is very easy for doing calculations. So this is your introductory part. Now the next one, determination of hardness of water. Determination of hardness of water. So till now we discussed that what is hardness, what are the reasons for hardness, how many types of hardness, how to measure hardness. Now we are going to discuss about how to determine. That means if a sample of water is given to you and we need to calculate what is the hardness present in the water. So how to determine this hardness of water, that is we are going to discuss now. So determination of hardness of water can be done by three different methods. One is soap titration method. Next one, O. Henry method. And the next one, complexometric method. Complexometric or EDTA method. So these are the three different methods we have. So titration method, O. Henry method and EDTA method. But according to our syllabus, we have EDTA method. Now we are going to discuss about this EDTA method in detail. So EDTA. So this EDTA method here, we have three different stages here. The first one is standardization of EDTA. You see your first step. Second step, calculation of total hardness of your sample. Calculation of total hardness is your second one. And third one, calculation of permanent hardness. Calculation of permanent hardness is your third step. There are three different steps we have. Before going to start this process, let me explain you what are the glass apparatus required for this experiment and what are the chemicals required, what are the steps to be followed. First one, coming to the chemicals. So the chemicals what we require are, first one, EDTA solution. We require EDTA, we require indicator, we require buffer, standard hard water, distilled water. So these are the chemicals we require here. And coming to the operators, we require burette, conical flask, beaker, funnel, standard flask or volumetric flask, filter paper, hot pan. So these are the operators we require here. Now move on to the procedure, what to do. First step. So first step is standardization of water. Standardization of water of your EDTA. So your standardization of EDTA by using standard water. First what we need to take the burette. Fill the burette with EDTA. Now take the conical flask. And in the conical flask, take sample hard, that means standard hard water, followed by indicator, followed by buffer. It is your hard water. We need to take 50 ml standard hard water, followed by 1 to 2 drops of indicator, followed by 5 ml of buffer. Before going to explain this one, let me explain you about the chemicals first. So here we are using EDTA, indicator, buffer. So first one, EDTA. What is the full form of EDTA? EDTA means nothing but ethylene diamine tetraacetic acid. Ethylene diamine tetraacetic acid. So if you take the structure, we have ethylene CH2 diamine. So that means 2 nitrogens will be there, and tetraacetic acid CH3COO minus, CH3COO minus, here also same, CH3COO minus, CH3COO minus. So ethylene CH2. Next, diamine. So how many nitrogens should be there? Ammonia means NH3. So we have amine means in the place of hydrogen we have some other compound. So we have 2 acetate and 1 CH2 here. So ethylene diamine. How many acetates are there? 4 acetates. So ethylene diamine tetraacetic acid or tetraacetate. This is about your EDTA. These EDTA titrations are known as complexometric titration. Why these EDTA titrations are known as complexometric titration means this EDTA can form the complexes easily. It forms the complexes easily. Because of that reason, this titration is known as complexometric titration. Next, this is about your first chemical. Coming to the second chemical, indicator. So the indicator is used to identify the end point of the titration. It is used to identify the end point of the titration, and the indicator which we are using are EBT indicator. We are using our EBT indicator which is blue in color. Next one is buffer. So the buffer which we are using are ammonium chloride buffer. Ammonium chloride buffer. So the buffer which we are using are ammonium chloride buffer. Okay. Now, why it is the necessity of using indicator? So we know that for a titration to identify, definitely we are going to observe a color change. Why the color change is taking place means as we are adding indicator to your solution. When indicator is added, what is happening here means it is forming the unstable complexes first. Because of that reason, it is giving one color. When it is titrated against your titrant, that means against your burette solution, the color is changing from the initial to the final color. Why the color changing is happening means it is because of the completion of your reaction. When the reaction is completed, then automatically the color will changes. Okay. To identify the reaction endpoint, indicator is used. Next one, buffer. So what is the use of buffer? So buffer is added to maintain constant pH throughout the experiment. Suppose if you take any titration, what is happening here means when we add the solutions from the burette, when the solution is getting running down from the burette to your conical flask, there may be a change in the pH value. That means acidic nature changes to basic nature changes to acidic nature. To overcome that problem, to maintain constant pH throughout the experiment, we are adding a special solution known as buffer. So buffer is used to maintain constant pH and indicator is used to maintain the end point of your titration, and EDTA is used to know the complex formation. Okay, these are the importance of each and every chemical. Now move on to the process. So first, burette is filled with EDTA and take the conical flask. In the conical flask, take 50 ml of your hard water, followed by the indicator, followed by buffer. Now what is happening here means the solution color changes to wine red color. The solution changes to wine red color. When it is titrated against the burette solution, this wine red color changes to blue color and stop the titration, note down the reading. Okay, like that you need to do the experiment twice. and take down the average value as V1. V1. Now move on to the second step. So in the second step, what we need to do? Same. Take the burette, fill the burette with EDTA. Here burette is filled with EDTA, and take the conical flask. In the conical flask, we need to take 50 ml sample water. That means either it may be from your house or it may be from college tap water or anything else. Which sample you want to identify, that sample is taken here, followed by 1 to 2 drops of indicator, 1 to 2 drops of indicator, followed by 5 ml of buffer. Again, what will happen? Solution changes to wine red color. Now titrate it against your EDTA. Then wine red color changes to blue color. Repeat the experiment twice and note down the value. So you will get your V2 value here. You will get your V2 value from the second step. Now move on to the third step. Move on to the third step. In the third step, we need to do little bit work here. So what we need to do means, here in the third step, we are going to calculate the permanent hardness. That means water should not contain any temporary hardness causing salt. We need to remove that one. For that sake, what we are going to do, take the beaker, 250 ml beaker. In that, take 100 ml of your sample water. Later, heat it on a hot pan. Heat it on a hot pan. Heat it on a hot pan until that volume reduces to 50 ml. Now transfer this solution into standard flask by using funnel and filter paper. Transfer this solution to standard flask by using funnel and filter paper. As we are filtering the solution, what is happening here? The temporary hardness causing salts are completely removed by using your filter paper, and the leftover filtrate will contain permanent hardness causing salt only. Okay, we need to take this sample now. Now same procedure, take the burette, fill the burette with your EDTA, take the conical flask. In the conical flask, take boiled water. Take boiled water, 50 ml of boiled water, followed by indicator, followed by buffer. Again, it will changes to wine red color solution. This wine red changes to blue color. Stop the titration and note down the reading. But here you need to observe one important point here. The filtrate that we are getting is only 50 ml, right? But we need to do the titration twice or thrice until you get your concurrent value. For that sake, what we are going to do, we are make-upping this solution to 100 ml by adding distilled water. We have only 50 ml here, but we are make up to 100 ml by adding distilled water. Later, from that sample only, we need to take the boiled water into your conical flask. Okay, now we get your V1 value from the first step, that is standardization of EDTA. V2 value from the second step, that is calculation of total hardness. V3 value, that is your calculation of your permanent hardness. Now we move on how to calculate the temporary hardness. Before going to that step, let me explain you why the solutions are giving wine red color, why the solution color changes to blue color. See here. First, water consists of calcium and magnesium ion. This is the basic principle involved in it. When it is reacted with your EBT, your indicator. So this EBT means nothing but erythrome black tea. Erythrome, it is your erythrome black tea indicator, and it is your blue color. It is in your blue color here. Okay, now what is happening here means calcium EBT, magnesium EBT is forming here. That means this is a unstable complex. Unstable complex, and this unstable complex color is wine red color. So why the wine red color is happening means here indicator is just reacting with your calcium and magnesium ions and forming calcium EBT and magnesium EBT. Because of that unstable complex only we are getting your wine red color. Later what is happening here? This calcium EBT and magnesium EBT are reacting with your EDTA. Then what is happening here means this EBT is ejecting out and forming calcium EDTA complex, magnesium EDTA complex. So these complexes are forming with the ejection of EBT. This is a stable complex. Okay, but why the ejection is happening means because whenever the EDTA is come closure, automatically EBT will eject out. Because of that ejection, the color changes to blue color and the color of your complex is colorless. The color of your stable complex is colorless. But why the color is changing from wine red to blue color means because of your ejection of your EBT. To maintain the constant level of pH, when we are adding the buffer now, that buffer should be 9 to 10. So this is the basic principle involved in it. This is the basic principle involved in the titration, in this determination of hardness of water. Now, calculation part. Calculation. So in the calculation, we need to determine your total hardness. We need to determine permanent hardness. We need to determine temporary hardness. Okay. Now, total hardness. How to determine total hardness means we know V1 value, V2 value and V3 value, right? So, total hardness can be determined by V2 by V1 into 1000. We will get your total hardness in terms of ppm. V3 by V1 into 1000. We will get your permanent hardness in terms of ppm. We know that total hardness is equal to, what do you mean by total hardness? Temporary plus permanent. So we know total here, we know permanent here. Then how can we calculate temporary? Temporary hardness is equal to total minus permanent. You will get your temporary hardness ppm. So in this way, we can determine the hardness of your given sample by using EDTA method. Now, just brief about your previous class now. What is our first topic? Is how many types of water are existing on the earth? Why water is known as universal solvent? Next, why soft water is giving more amount of lether, why hard water is giving less amount of lether means it is because of your calcium stearate, it is giving less amount of lether with your hard water. Because of stearic acid formation, it is giving more amount of lether with the soft water. Next, why hard water is giving your calcium stearate means it is because of your hardness, that we discussed it there. And later we discussed how many types of hardness, temporary and permanent, how to measure hardness, what is the relation between the hardness. Later we discussed about why all your hardness causing salts are converted into calcium carbonate equivalents means it is because calcium carbonate is highly insoluble and molecular weight is 100, which is easy for calculation. And later we discussed how to determine hardness of water. We have various techniques, but EDTA is the best method to determine hardness of water and that is included in our syllabus. And what is EDTA method? What are the chemicals required for that procedure? What are the operators required for that procedure? What are the steps involved in it? And later we discussed about what is the principle involved and why this wine red color changes to blue color. And under class we discussed the calculation part, how to determine total hardness, permanent hardness and temporary hardness. So up to this we discussed the introductory part and the determination of hardness of water. In the next class we are going to discuss about the municipal water treatment. That means the water that is coming to your home consists of impurities now. So before coming to our houses, what are the steps followed by the municipal people? That we are going to discuss in the next class. Thank you. Thank you so much.
Like, share, and subscribe. Hit the bell icon for more updates.